And so my job is to talk to you about advances in chronic kidney disease and end-stage kidney disease therapy. I just love this slide. So there's a bunch of different things I'm going to talk about, and the first one is trying to keep your kidney that you have functioning longer, whether you have a transplant or whether you have your own native kidneys with cystinosis. So there's a group of drugs called the SGLT2 inhibitors, and in the business we call them flozins. There's canagliflozin, dapagliflozin, dapagliflozin. And they reduce the reabsorption of sugar in the proximal tubule. So right here, the filter filters the blood and lots of sugar comes out, and the proximal tubule is supposed to reabsorb all that sugar. And then in cystinosis, the proximal tubule doesn't reabsorb the sugar, and that's why so many of these children have sugar in their urine, and sometimes they're diagnosed with diabetes at first. Well, anyway, this drug actually prevents you from reabsorbing that sugar, and it initially was marketed for diabetes, but it's not terribly good for diabetes, but it turned out it had all sorts of other non-diabetic effects up and down the kidney. And in fact, using these drugs actually preserves deteriorating kidney function. So this is a graphic of time, and this is a placebo-controlled trial of one of the flozins versus a sugar pill. And so this is the kidney function. So normally the GFR is above 90, right? So these people on average are about 35, 38. And these were the people on the placebo, okay? Just losing their kidney function over time. And this is not cystinosis. When you put them on a flozin, the GFR drops a little bit all of a sudden, but then it stabilizes, so in the long term, it actually stays better for much longer. And these drugs are now believed to have a 30% benefit at delaying the progress of kidney disease, but also delaying the progress of heart disease. Okay, so cystinosis patients leak sugar anyway, so why do we care? Well, the reality is that these drugs do a bunch of things in other parts of the kidney. So as we look at your kidney, you know, they're deep in your body, and as we magnify them, there's a cut section of the kidney, and then here's one of the filters, the nephrons, and then you focus on the glomerulus, okay? The glomerulus is the filtering apparatus. So when kids are young, all the problems are in the tubules. The tubules aren't reabsorbing things, and you leak and you pee huge amounts. But what actually buys you kidney transplant and dialysis is when these filters die, and that happens later on in cystinosis. So when you go a really high magnification, the individual glomerulus has these filters, and each filter is covered by this beautiful network of podocytes, and they have these long fibers that sort of interdigitate between each other and control what's being filtered. And this takes a huge amount of energy. And in a damaged filter with chronic kidney disease, this beautiful network is just destroyed. It turns out in cystinosis, this may be a valid target for improving people's kidney function. And we are now finding data that shows the flozins are actually improving glomerular function. In the cystinosis research, you're going to hear more about that later from other speakers. Autophagy is a big issue in the cells of the body, and the SGLT2 drugs actually help this improve. The flozins also reduce inflammation. Many patients with cystinosis are believed to have inflammation. It's one of the reasons they feel weak and tired and have deterioration of many parts of their body. And the flozins actually reduce total body inflammation and scarring markers. And there's data that shows the flozins directly interact with liver cells and inflammatory cells and cells of the intestine and also the heart. And so when people look at the genes that are affected by the flozins, there's all sorts of important genes that we hear about in cystinosis research to do with inflammation and to do with growth factors and this thing called mTOR. So the cystinosin protein isn't just a pump to get rid of cysteine. The cystinosin protein interacts with the energy regulating and signaling mechanisms in the cell, and that all revolves around mTOR. So the SGLT2 inhibitors actually interact with mTOR as well. And so these may actually be drugs that can help people with chronic kidney disease of cystinosis stabilize. And I'm now seeing in my consultation clinic some patients that are on these SGLT2 inhibitors being put on by other doctors. So this actually could be a real important thing as because we're getting to know, but this is still preliminary. But the other thing is the flozins actually protect your heart. So this is a graphic showing, these are adults with kidney disease, and these are the risk of developing major adverse cardiac event with placebo versus empagliflozin. And so the flozins don't really affect your blood sugar that much. They help you lose a little bit of weight, but they have a profound effect on the heart. So we're starting to use these as primary treatment for anybody with chronic kidney disease in their teens. Iron stores. You may be being nagged by the doctor, your iron is low, take iron, and iron makes you constipated, iron gives you tummy pain, it's hard. But what it turns out is iron is really necessary to prevent heart failure in adults, and this may also have a relevance in children as well. So this was a huge study where they looked retrospectively at the iron saturation of adults with kidney disease, and normally we want to get it 20% or better. And they found that if your iron saturation was less than 20%, you had double the risk of heart failure. But when they broke that down, what they showed was over a period of 10 years, the people that had the worst rates of heart failure had an iron saturation less than 20%. The people with the best rates of heart failure had an iron saturation of 40%. So really aggressively improving iron stores. So we're starting to use more and more IV iron in our CKD patients. And I have cystinosis patients who are on Pro-Sysby, they still have belly pain, and they say, I just can't do the iron. So I'll bring them into my infusion center and give them a big dose of IV iron a couple times a year to maintain their iron status, maintain their anemia. And in adults, this is actually being shown to protect you from heart failure. The big drugs in the world are the GLP drugs. These are the Wegovy's, exenatides. They're getting so much press for weight loss. They were originally for diabetes, but as we found out that in bigger doses they can actually be useful for weight loss, what you're noticing is media people on the news, the news readers, all your politicians, Donald Trump, they're losing an awful lot of weight. And most of them, it's probably because of this stuff. But the data is also coming out that GLP-1 drugs may directly protect your heart from heart failure if you have chronic kidney disease. Maybe not as good as the flozins, but there's very interesting data coming out that they may be synergistic. So obesity is a major problem in people with chronic kidney disease, and we may be seeing more and more people on these drugs. Moving on to what happens if you have kidney failure, the wearable artificial kidney. There's people in Europe and in the United States working very diligently to develop a wearable artificial kidney. And this was patented in 2021, and it's a belt-like device. It's about 3 pounds, it's rechargeable. The problems still are that it causes clotting and vascular access issues, but for some people that are starting to use these devices, it's so much better than going to hemodialysis 3 days a week. It's working continuously, so you don't have the ups and downs of hemodialysis. And here's a picture they showed in 2022 of a guy taking a shower with the thing on. So I guess you don't get shocked from it, but I would still worry. But they're making advances in the artificial kidney world. How about kidneys being grown in the lab? The Cystinosis Research Foundation is funding some organoid work, and it's hopefully going to be very promising to develop ways to do research and do the treatments. But people are trying to get kidneys to grow to actually maybe one day serve as a transplantable kidney. And so people are using various culture mechanisms to take human kidney biopsies or maybe even cells from the urine and grow them in a test tube. And these are various samples of tissue, and they develop things like glomeruli, and they develop tubules. And this is one that you can see the tubules and things growing out of the thing. This is 3 months, and there's a glomerulus there. And they have all sorts of kidney staining, but they're still tiny. Are they ever going to get to be big enough so that we can actually implant them? Maybe not. It's hard to grow them that big without a circulation, but they may serve as a source of cells for 3D printing. And so this is a 3D printer, and in some preliminary studies in Israel, they have made small hearts with 3D printing. And just watch this time lapse. And these suckers beat. So, there is human work on 3D printed very simple structures. So on the left is a young person who had a deformed ear, and on the right is that ear which was 3D printed in the lab. The scaffolding was infused with that person's own cells and then surgically implanted, and this is one of the early post-op views. So we are getting 3D printed stuff happening in clinical trials, and maybe one day we'll get kidneys printed like that. The most interesting thing in the literature now, and the thing that I would, if I was a betting person, I'd bet on, is the genetically engineered pigs. So pigs have been helping humans for millennia, but pigs have all sorts of issues and concerns. And so for years, people have been hoping that we can grow kidneys for transplantation in pigs. And what's been happening was they've been genetically engineering pigs, and every year they throw in a few genes, take out a few genes. The latest pig has had 69 genes changed, either silenced or increased or altered. And these kidneys were initially placed in brain-dead donors, so people whose families gave consent, and they kept these donors alive for weeks. Now these people were brain-dead, and they implanted these pig kidneys into these donors. They've also tried in China, they've implanted a pig kidney into a human with pig liver into a human with liver failure, and they've also done a couple of humans who needed desperately a heart transplant. So one of the heart transplants failed because they had missed a virus. But what's really fun is 2 weeks ago, a 69 gene edited kidney was transplanted into a 62-year-old male who had his kidney transplant was failing, and he had contraindications, so he couldn't get another one. This was a company called eGenesis. They had had 3 edits to remove certain sugars from the pig that would cause instant rejection. They added 7 human proteins to prevent rejection, and they found 59 viruses that they removed. These kidneys have been transplanted into monkeys, and they work great for up to a couple of years. And this is the guy on discharge. So this African-American gentleman here, 2 weeks in the hospital, and he's out off dialysis. We have no idea how long it's going to work. We have no idea what the problem is. But this is truly the cutting edge. And I'm hoping that maybe before I retire or before I leave this world, we'll be able to find patients who are approaching dialysis or on dialysis, and we'll be able to get a blood test and call up your local Safeway and book a kidney that can be grown. Because it only takes about 6 months for a baby pig to grow into the size where the kidneys are similar to adults. And so we may be able to get rid of, depending on human kidneys at some point. And if you can engineer them so that they are so compatible to your own patient, maybe we won't need immunosuppression. So this is really cool. Allocation. When I started doing this, and even into the late 1990s, if you were a white kid, you waited a lot less for an organ transplant than if you were a black kid. And there are a bunch of different reasons that are structural and financial. But what you can see here is the waiting time for a kid on the wait list. This is transplants per 100 patient years. Whether you're white or black or Native American, roughly the waiting time is about the same for a deceased donor. There's some variation from year to year, but in general, kids waiting for deceased donors now have about the same waiting time. And that's because we changed allocation policies to ensure that kids of certain genetic or geographic heritage don't wait any longer than others. And this is a real win. What's not a win is the fact that we don't do enough living donor kidney transplants. So this is data on deceased donors and living donors and how long the kidneys last. And basically, the most recent data is, and what I tell families when they come into my clinic for a kidney transplant evaluation, if you get a deceased donor kidney, on average those kidneys last 11.5 years. If you get a living donor kidney, those kidneys last 19.5 years. And the differences between deceased and living is getting bigger. Back in the late 90s, the difference was only 4 years. But now it's almost 8 years. So living donor is preferred for this reason, and also because if you get a living donor as your first kidney, it's going to wear out. If you're 20 and you get a kidney that's going to function for 19 years, when When you're 40, you're going to need another one. So when we have patients in our pediatric kidney transplant clinic, we tell them, this isn't your only kidney, this is your first. And you have to think about it from that perspective, because you are always a kidney patient. When you go in for your second kidney transplant and you've had a living donor for your first, the second one tends to be easier because of immune issues. So, what's the living donor rates in kids? Plummeting. So back when I started in the 90s, 40% of kids got a living donor kidney from their parents. And you can see this is parental living donation dropping. We're seeing living donors from other family members, siblings, friends, teachers, about the same. Why has this been dropping? The data shows it's parental health. The expansion of obesity, the expansion of diabetes, and also as over time demographics are changing in U.S. society and there's more and more kids in single family households, and having a single parent provides substantial economic barriers. So these can be overcomable, but this is really a problem. So this data is up to 2011. It's not getting any better. So this is pediatric kidney transplant rates up to 2022. This is deceased donors. So in the US, we're doing about 500 pediatric kidney transplants a year, gradually increasing. This is living donors, continuing to drop. So, we have had to really look at being risk averse and what is the right thing to do for kids. So, for many families, they say they prefer a living donor, and we have someone who came forward, but the kidney was inappropriate. We want to stamp out that concept. There almost is never an inappropriate kidney for living donation. We have swaps. So what's a swap? Say mom wants to donate her kidney to her son, but can't because of a blood group problem. Another pair, husband wants to donate a kidney to his wife, but can't. Mom can give her kidney to this guy's wife. His husband can give his kidney to mom's son. That's a swap. Everybody wins. There are chains where it starts with maybe a Good Samaritan donor. And we've done a few of these in my hospital. They give a kidney to someone who couldn't get a kidney otherwise, but this mom had wanted to give the kidney, and that triggers a domino effect. That mom can give a kidney to this person, who then couldn't give the kidney, but they can give a kidney to this person. And sometimes in the news you see chains of 40 people being generated by it all working out through a computer algorithm. These used to be done all the same day, and it was complicated. And you were always afraid, well, what happens if I give my kidney, I'm in the OR, and my kidney's coming out, and then the donor's supposed to give the kidney, bails, runs away. We don't do these anymore because we have the National Kidney Registry. And this is something that we're needing to do more and more in pediatrics. We were slow to get started, but we're now aggressively educating our potential families about the National Kidney Registry. And we are getting a lot of people now doing a voucher. What's a voucher? So, you want to donate your kidney, but it's not the right time. You're not compatible with your intended recipient. You're compatible with your intended recipient, but a better match is possible. You want to donate now, but your kid's only 5, but you don't know, am I going to be here in 10 years because I like to skydive? I'm healthy, this is the time for me to donate, I don't want to wait. Or you want to protect your family members. You donate your kidney now to the NKR, and you get a voucher. So when your kid or 5 other family members that you designate need a kidney transplant, you can get one from the NKR. So we now have people where they say, granddad is 50, so he's too old to give to a 5-year-old. Give to the NKR, and then we can get a younger kidney back. Mom wants to donate, but she's not got the right blood group. Voucher to the NKR. Dad wants to donate, but he's got 3 arteries, and we don't want to take the slightly increased risk of thrombosis. Someone will. And then you can get a better kidney back. So, right now, as of today, because I just put this slide together this morning, there's nearly 9,000 kidney transplants in the US that have been facilitated through the NKR. And at my program, we have a number of parents who have gotten a voucher. And so our kid is already, whenever they get close to dialysis, we'll just click the voucher button, we'll look for the best kidney available, we'll give it a few months, and we'll be able to transplant that kid and avoid dialysis. this is a real improvement. Transplant centers are under the pressure to avoid risk. You know, when you're in a kidney transplant center, you are scored for your outcomes by the government, by UNOS, by SRTR, by insurance companies. If you're anything but perfect, insurance companies will say, we're not going to send patients to your center, or you're going to get audited. So there are many kidneys that maybe have an 80% chance of success that some 60-year-old guy on dialysis would love to get off dialysis. And this guy's never going to get off dialysis because we have over 300,000 Americans on dialysis today. Only 100,000 are on the wait list because we know most people will never get a kidney transplant if they're adults, especially if they're older. And only 25,000 kidneys are transplanted every year. But we're throwing in the trash kidneys that have an 80% chance of success because the transplant centers are scared. So that's something, and when we've talked to patients, many would gladly accept that risk. So the same thing goes back to living donation. I have patients where we've evaluated them and they were slightly higher risk, and now we're reassessing age. We used to say, 40, 45, we shouldn't, but now we're aggressively using the voucher program. I have transplanted kidneys from people who died with a fentanyl injection in their arm. We never used to, and they do great. These are young, healthy people, unfortunately. Untreated or previous TB, I have transplanted patients where their donor had untreated TB, and we said, okay, we can treat the TB in the kid for 3 months, you're done. And parents were informed, you want to get this wonderful 22-year-old kidney, or do you want to just wait and see what happens? They said, we'll take the TB treatment. Coccidioidomycosis, which is common in Arizona, in Central California. We have patients where they're donor positive, we can treat that. I didn't put histoplasmosis on there. Histoplasmosis, which is more common in the East, we can treat that. Toxoplasmosis, we can treat that. I have transplanted all of these patients where the donor was positive for these, and we were able to successfully treat the kid, prevent the problems, and have a great kidney. 5 years ago, 10 years ago, I would have said no. Hepatitis C, I've not transplanted as a hepatitis C positive donor. We know we can cure hepatitis C, but they're doing it in the adults all the time. So we're opening up our eyes to the possibility that there's such a tremendous benefit to living donation that we need to reassess all that. Okay. Another area in care of chronic kidney disease is there's a lot of discussion in the community of people who are living with an organ transplant about biomarkers, ways to predict that you have rejection of your kidney from a blood test or a urine test to avoid biopsies. And biomarkers, there's a huge clinical need for biomarkers in various aspects of clinical care for diagnosis, prognosis, monitoring, surrogate endpoints for research. And biomarkers can come from biopsies, where you do a routine kidney biopsy at regular times, and non-invasive, such as urine or blood tests. But I just want to take you through some of the science as opposed to some of the hype. So cell-free DNA has gotten a lot of press, so anybody who's on a patient advocacy group or in 5 minutes, okay, or has been involved in any sort of transplant community have heard about cell-free DNA as being a way to detect rejection without a biopsy. And what they've shown in this first study was if you get a kidney transplant and you get a blood test, most people have a level less than 1, most is less than 0.5. And then what they've shown was if you have a level less than 0.5%, your odds of having 4 years without developing donor-specific antibodies, without having rejection, is much better than people who have a level of about 0.5. Okay, that's good. They then started looking, though, at how reliable are these tests, and depending on where you set the cutoff, you can be very specific and not very sensitive. Sorry. You can be very sensitive but not very specific. Or if you set the cutoffs at higher numbers, you can get to the point where it's so when you set the thing at higher numbers, it's very specific but not very sensitive. So if you say, okay, I'm going to biopsy everybody with a 1 or above, you're going to be biopsying 5 people you are going to miss 5 rejections for every one you biopsy. So there's a lot of controversy about where to set the number. Well, then a whole bunch of other labs got involved with gene testing, and these are $2,600 a pop. So one was called TrueGraph, one is called T-Rex, one is called CTOT8, and all these are different gene testing with blood tests, trying to say, you don't need a biopsy, you don't need blood tests, you just need these gene testing. And they're all more than $2,000 per blood sample. So Medicare changed the rule in 2023. They said performing these tests were not compliant with the policy, whether you could only do them in very special things like with a special protocol or instead of a biopsy. Because Medicare doctors were starting to order them monthly, and Medicare was going broke. So then they reviewed this and said a kidney biopsy itself has a Medicare cost of $1,500, yet one blood test was $2,800, and some of the doctors were ordering them monthly. So then what happened was Medicare said you can't do that anymore. And they looked very closely at economic analysis and said maybe screening for 2 or 3 times for people who are aged less than 35 would be economically beneficial. So then what happened was industry got patient advocacy groups to go crazy, and there was all sorts of subtle pushes by industry and not so subtle pushes, honor the gift campaigns. A lot of journals had these articles placed. Here's various organs were all complaining about this. And then another group started saying, well, we have a blood test which is a little bit less expensive and is perfect for predicting rejection. And this is the senior author of this blood test. And they had a couple of trials that they ran all the samples, and it looked like it was really good. And they sold it to an international diagnostic lab company, and then it was tested outside of their lab. And the data showed that assay had no diagnostic value for rejections. There was all sorts of hype. They sold this for a lot of money to a diagnostic company, and when it was actually used in real world, it was useless. So then another group said, well, maybe we should do cell-free DNA and the genetic testing with genes. So they combined them. And what they showed was in a bunch of 420 biopsies from 200 patients, the yellow was rejection patients, the blue is no rejection. The dark blue is the cell-free DNA, the green is the gene expression studies, and they don't match. And there was all sorts of patients with rejection who were missed, and all sorts of patients with no rejection who were positive. Doing these tests together was what they recommended. Combining them, it's even better. $8,000 a pop. And so they put together this protocol, and they started selling them to Medicare patients, and then Medicare said, no way. We can't be spending $8,000 for a blood sample. Look, if this was a $25 blood count like a CBC, we wouldn't have having this discussion. This would be great to be doing these tests all the time. But you just can't, because this company disappeared. So now people are looking at urine testing, so with more easy tests, which won't be so expensive. So these are chemokines 9 and 10. And then the same PI came up with a urine kidney injury test, which is a mixture of urine cell-free DNA, methylated cell-free DNA, clustering, CXCL10, total protein, and creatinine. And they said this gives outstanding results, and they called it a KIT score at predicting rejection from non-rejection. One test. They changed the name to something more sexy called QSANT, and they formed the NephroSant company. DaVita, a national dialysis chain, funded them for $16 million for a startup company, and they advertised, and they had in banners that they were launching a 2-year study of 2,000 kidney transplant patients. And then a whistleblower came forward. There were huge problems in the lab, not following Medicare rules, not following policies and procedures. The company ousted the founder. The founder sued the company, And the company did an external review, and they were going to publicize the results of the external review, and the founder sued the company to shut them up, to gag order them. And it was just ruled on in May that the dispute said that they had found wrongdoing by the plaintiff, that the plaintiff wanted covered up, and there was no rationale to cover up the internal investigation results. So this Nefrosant company, which got all this money, which was supposed to be the be-all and end-all for predicting transplant rejection, is now disappeared. It's gone. Research is messy. We learned that in COVID, right? And there's, science says one thing one week, another thing another week. Don't give up. Money, capitalism are important. That's what pays the bills. But you get ego and hubris of investigators. Things always take longer than hoped. Back when I was, I had hair, I remember when Larry had hair, they were talking about organ transplants from animals, and we still aren't there, 30 years later. Findings must be consistent and be able to be replicated by outside labs, outside institutions. The scientific method continues to lurch forward through open dialogue, continually reassessing outcomes, criticizing openly and honestly. Sooner or later, if there's fraud, it will be revealed. It always is. Truth is what stands the test of time and continued scientific challenges. So don't give up. We are making progress, but it's 2 steps forward, 1 step back. Anyway, thank you very much for your time. Sorry I'm over.